So we're going to look at complex numbers today. Well, let's consider what we have in front of us here. So you may recognise this as the quadratic formula. Now, you may have tried to use the quadratic formula in the past and ended up getting an error when you type that in your calculator. And that will normally be due to the fact that this bit here under the square root becomes negative. Now, this bit here is known as the discriminant. If you get a negative discriminant, that means you've got a negative square root, and we cannot have negative square roots. That's where you get an error, unless we use something which is called I. I stands for an imaginary number, and it is the square root of -1. We can use I to actually get answers to things like this, where we do get a negative discriminant, and it is called an imaginary number. So an imaginary number is in the form of BI. So B is any real number. Do the weird R thing, which I'm not very good at drawing. Then let's talk about complex numbers, because the title says complex numbers. So a complex number is any number that has both a real and an imaginary part, and that is in the form A plus BI. A is the real part of our number, and BI is the imaginary part of our number. So complex numbers have both real and imaginary parts, where both A and B are just, again, any real number. And we'll talk about what exactly we mean by real numbers in a moment. If we have a look at the following diagram here, this is basically how we can define any number. So let's talk about what's going on here. So natural numbers are numbers that we can count in. So that will basically be any positive integer. So some definitions include the number 0, others don't, but it's numbers that we can count in. Natural numbers, they do not include negatives, whereas integers, you can see natural numbers fall within integers. So integers are including negative numbers. So -10, -5, it definitely includes 0, and obviously all the positive integers as well. And then rational numbers. So integers all fall within rational numbers, and rational numbers, are any numbers we can write in the form A over B, where A and B are both integers. So we can write, for example, a fraction, a quarter, or we could write something like 0.7, which becomes 7/10. Then we have our irrational numbers, and our irrational numbers are numbers that are not rational, aka we cannot write them as a fraction where A and B are integers. So that will mean things like surds, so things like √2 and other surds that can't be simplified to become integers, and things like pi. So anything where we cannot write it as a fraction in the form A over B, where A and B are integers, and then all of those numbers fall into our real numbers. So irrational, rational, they're all real numbers. Then we have our imaginary numbers, which is where I comes in, being the square root of -1, because we know we can't have the square root of -1. And then we can see that complex includes real and imaginary numbers. So complex numbers will always have a real part and an imaginary part. So now let's have a go and practice writing the following numbers in terms of I. So let's have a look at the square root of -36. So let's think about, we can separate that into the square root of -1 multiplied by the square root of 36. The square root of -1 we can write as I, and root 36 would be 6. So that would just become 6i. And the I typically goes in front of our number. Then the square root of -4, same again, we can split that into the square root of -1 multiplied by the square root of 4. Square root of -1 we can rewrite as I, and the square root of 4 becomes 2. So we get 2i. then the square root of negative 7, we can rewrite as the square root of negative 1 times by the square root of negative 7. Now in this case, 7 does not simplify any further. That is a surd, and we can't take any square numbers out of that. So that will just become I times by root 7, and that will just become root 7I. And then root of minus 45. So again, we can split that into the square root of negative 1 and the square root of 45. But this time we can definitely take square numbers out of there. So root 45, I know I can split into root 9 times by root 5. So then square root of negative 1 would become I, root 9 would become 3, and then root 5 will stay as root 5. So that will get us 3 root 5I. So we can also simplify complex numbers, and we can gather all the real parts of our number and all the imaginary parts of our number together to put it in the form a plus bi. So for this one, we're going to look at the real parts of our number. So we have the 2 and the 4, so that will become 6. And then the imaginary part of our number, which is 3i plus another I, so that will just give us 6 plus 4i. So as long as we keep the real bits together and the imaginary bits together, that's absolutely fine. It's I minus 3 lots of 2 minus I. So I first will just expand that bracket out, so I end up with I here minus 6, and then we have a minus 3 times by minus I, so that will give us plus 3i. Then the I plus the 3i will give us 4i, so that will be minus 6 plus 4i. So we have 10 plus 4i over 2. So both of these are divisible by 2, so that will become 5 plus 2i, and that's it. It will just become 5 plus 2i.